Hello, everyone. My name is Steve Stadowski. I'm the platform manager for the Galvanic Applied Sciences Monitek Ultrasonic analyzers. Today, I'll be presenting an introduction to the Monitek Ultrasonic. We'll cover the measurement theory, analyzer design, and installation and maintenance. Monitek Ultrasonic is a two-part system similar to our optical, where we use the AT3 ultrasonic transmitter connected to the ultrasonic AS3 sensor via cables. Works on an acoustic backscatter, which means we send out an acoustic pulse and we listen to the echo return proportional to the higher or lower ppm values. We typically use these to do oil and water measurements in high-level suspended solids where an optical device would fail because of window coatings or too dark of a sample to allow the light through. This is our second generation. Past generations were called the AS1 and AT1. And this is the AS3, AT3. Over 30 years, we've been producing these analyzers, and it offers the best price to performance ratio available on the market. In fact, we're the only acoustic device on the market of this type of design from very low levels to very high levels of ppm value. It really truly is a maintenance-free analyzer. Unlike an optical device where the windows can get dirty or the lamps can burn out, this does not have those issues. It will work even if the sensor tip is coated with some particulates. So obviously no one has to go out there and do any maintenance. Sensor removal, we can do this. It is installed through a sample gland fitting and ball valve with safety chains, so you can hot tap remove it or insert it. Instantaneous response time, under 1 second. So it's quickly going to alert you to any process upsets, eliminating any loss of money or expense during a downtime event. Our sensor configuration is very customized for the application. We can make the sensor length custom. We can have custom valve to insert it or a custom flange welded to the probe. It just all comes down to us taking a look at the custom application need. It simplifies installation. It will just be turnkey at that point when they receive it. Very robust sensor design, handles temperatures up to 150 degrees C and 260 PSI. No requirement to cool your sample or pressure regulation as long as it fits in that range. Here's some of our key applications. In chlor-alkali, we can measure suspended solids in the brine purification process. Food and beverage for filter breakthrough. Suspended solids measurement. Oil field production, this is where we do an awful lot of produced water measurement for oil in produced water. Again, in SAGD production in Canada, we also do the same produced water application for oil and water detection. There's a nice application for oil and water also in refineries at the desalter effluent outlet, and some wastewater treatment applications prior to sending this water into the municipal sewer. Here's just a quick and easy of how the analyzer actually works. So the transducer applies a pulse to a piezoelectric crystal in the sensor head. And as you can see here, it generates what we call the main bang, or that is the sound generated, either a 5 or 15 megahertz. And what happens is if there's any particulates in it, or if we're talking oil and water, oil droplets in the focal region, it will respond and give a echoed pulse back. In the proportion or size of this echo back is proportional to the ppm. So what happens is we have a calibration table that it looks at, and depending on the amount of counts we have come back, it looks it up on the table and will output that as the calculated ppm value of either suspended solids or oil and water. We offer these again at either 5 megahertz or 15 megahertz. A 5 megahertz is for higher range, from anything from 2,000 or 2,500 ppm up to about 1 or 2%, depending on sample and actual application. Or we can offer, for low range detection of the 0 to about 2,500 ppm with very high sensitivity, offer a 15 megahertz tip. Here we look at just an example of the main bang pulse being emitted, the echo return particle, the particles that echo them in the measurement window, and also, as we see on the other side to the right, is the main bang echo being reflected from the actual sample or the piping back wall. So when we install these, we want to be careful to at least have a minimum of 3-inch piping so that the echo created from the far wall does not interfere with the measurement window echo section. So some of the sample requirements, obviously less than 260 psi and less than 150 degrees Celsius. We offer custom sensors in any material available. As long as it's available, we can make them. Standard is 316 stainless steel. I would say a good second place that we do is Hastelloy C. We've done Monel, titanium, etc. So all based on the application and sample requirements, we can design a sensor to meet that application. The O-rings that seal the gland and the sensor tip, standard is Viton, but for some nastier samples that would attack Viton, we offer up to Calres. The sample tip is made out of PEEK. The gasket between the PEEK tip and the metal probe shaft is always Calres, and we offer cables up to 100 meters in length. The standard probe length is approximately 10.5 inches long, and that is also custom built depending on application and sizing of your pipes or the riser coming off of your pipe. Here we're looking at some different transmitter design. Standard is a fiberglass NEMA 4X box, and that's for general purpose for the transmitter. Or we can offer, as we see in the photo here, the NEMA 4X stainless steel box with Z-Purge for Class 1 Div 2 installations. The sensor always, no matter what, is Class 1 Div 2 rated. What's required to power this unit up is the universal power, 90 to 265 volts AC, 50-60 hertz. It draws approximately 15 watts when in use. And again, we have the unit certified Class 1 Div 2 with instrument air purge or a Z-Purge. The sensor for the Canadian market also carries a CRN registry for the pressure holding initiative. The electronics enclosure, the transmitter. So all these are connected to one sensor, so therefore it's got one analog output and 4 programmable relays. The membrane touch panel, the user interface. So obviously it can be locally set up. All set points are done from this. You don't have to bring a computer out to it. Here we're taking a look at the sensor design. So as you can see, the standard over here on the left is you have a preamplifier connected to the probe shaft, goes through the gland fitting with safety chains and ball valve. So that's how it is able to be installed on a piping that is running full of fluid, or also removed without shutting the process down. There's a picture in the middle of the sensor tip with the focal optics of the tip. And on the left-hand side, it shows just a diagram drawing of our gland fitting and ball valve with safety chains assembly. So the way you would pull this out is have the safety chain on the long setting, pull it out. It gets just past the ball valve, so no sample leaks out. Close the ball valve, and now you can take the probe completely out of the gland fitting, and you could put it in a bucket of known standard water to do a quick QC test, Or if you wanted to do, call it quarterly maintenance, take a rag and wipe the sensor tip clean, and then just in reverse order, just install it back in with the valve open once it's in the gland, and then go down to the holding point, which is the short portion of the chain where it secures the sensor at the depth that we want in that sample pipe. Here's our standard Class 1, Div 1, Div 2 installation sensor design. Again, has the ball valve. This one has looks like a 300-pound, 2-inch or 3-inch flange. So that will attach onto a port in a sample pipeline. This one also has, for higher temperatures above 100 degrees C, if you look just below the enclosure, that Adelat enclosure, it has an air in and air out. That is an air purge for the cooling tip to keep the tip from getting too hot. So here we can see some of our sensor mounting guidelines. Obviously, we want to be downstream of, we do not want to be downstream of any flow disturbance. For example, pumps, flow meters, or air bubbles, that are being formed from these will also be seen. We want to be a minimum of 10 pipe diameters away from these types of disturbance. A little bit of back pressure can cut down on air bubbles present, which will allow the sensor to only see either the oil droplets or turbidity in the sample and not air bubbles. Typically like to be mounted on a vertical pipe flow to prevent any pressure drop, and also any air bubbles will not be able to stick in it. It will flow to the top. Again, vertical pipe is also best for high solids application. Some horizontal applications are fine as long as the flow rate is such that the flow rate and the flow volume is enough to keep the piping full of liquid and without any air gaps in it, which would create air bubbles. Here's just some examples of different ways that these devices are used. As you can see on the left side, there's one mounted in an open channel basin to do particulates or oil samples. Through the ball valve, which is hot tappable on a pipe, or with a flange mount, where on this one it obviously is not pipe mount, is not hot tappable or removable. You would have to shut down your fluid to remove that one and do any maintenance. Coming out of a tank or in piping, again, it's showing the importance of at least 10 to 15 pipe meters away from any elbows. We need at least 3-inch diameter because it's very hard to mount on smaller piping because the far wall is going to be too close to the sensor tip, and that will interfere with the readings. So again, at minimum of 3-inch diameter piping. If you do not have 3-inch diameter piping, you can make, or we can offer, one of these 3-inch to say 1-inch or 2-inch flow cells where the analyzer can be mounted to. As you can see, here's one mounted to fiberglass piping via, it looks like a 1-inch, 150-pound flange. So that's permanently mounted. Obviously, it's not hot tappable. And there is the corresponding AT3 transmitter with it in the fiberglass box. And here is one, it looks like in an oil field setting, doing oil and water measurement. And this is in a Class 1 Div 2 stainless steel box with the Z-perch. Really no maintenance on this device compared to an optical. There's no color or opacity interference because it is acoustic. It's, it will not affect any photosensitive samples, where if you're always shining a light, that can be an issue for certain customers. Does not care really about the density of the sample or the flow rate. And again, it is impervious to coatings affecting the results. Obviously, with any of our galvanic products, we offer local and on-site startups and trainings, FATs at our factory. So why Monitek Ultrasonic? No maintenance needs. There's no lamps to change. There's no windows to clean. Just sits out there and runs. Sensor design, obviously we can customize the sensor length or the type of mounting to meet the customer's requirement. Again, with sensor materials, for compatibility with their liquids, we can offer a multitude of materials. So we just need to see that from the application and talking to the customer. Sensor is not affected, again, by dirty or opaque samples or colored samples. Does not need any type of cleaning jet or mechanical wiper. If the sensor does have to be removed for any service or any preventative maintenance, it does not interrupt the process. Handles high temperatures and pressures. So if a cooler fails or the temperature does spike up to that range, there will be no damage to the sensor. Here we just show Monitek Ultrasonic as not really one size fits all, meaning if we look, obviously it works on acoustic backscatter, but we also offer a near infrared absorption probe for different ranges, depending on customer requirements. If we had to do 0 to 2%, we could choose either a ultrasonic or a Monitek CSK. Pros and cons of both. Multi-streamable with the CSK, it is. You can add up to 4 of them on one controller, where on the ultrasonic you cannot. It's only one sensor per transmitter. Again, both are completely customizable for the mounting or in customer requirements. Same types of interferences again. An optical or the Monitek CSK requires a cleaning jet, where the ultrasonic does not. So with the ultrasonic, we give measurement certainty, rapid return on investment. It sits out there all day long on the pipe, never misses an upset that happens, guaranteeing your product quality. It measures instantaneously, every second or less. And we've been doing these for 40 years in very difficult applications. So any questions you have, obviously address it first to your local representative or your regional sales manager for the products, or myself, platform manager.